Hi everybody. Today we're going to look at a different method of solving systems using a method called elimination. It's another algebraic method. First, it's important to just look at what you're given, that you're given two equations and that each of these equations represents a line, and that we're trying to find where the two lines intersect. That's what it means to solve the system. So always keep that in mind. Yesterday we used substitution because we had a variable that was isolated, like x equals or y equals, or a variable that was easily isolated because it had a coefficient of 1. And then we could just substitute in for that variable into the opposite equation. Today, the equations that you're given are not set up that way because all the coefficients of the variables are something other than 1. So if we were to isolate one of these variables, you would end up with a lot of fractions. And not that we don't want to work with fractions, but they are very tedious to work with and kind of make a big mess. So we have this other method called elimination. Now there is a typo in this problem. If you could please change this 6y into a negative 6y. Okay, so elimination, what it does is it adds the two equations together. So you're going to draw a big line and a plus sign, and you're going to add vertically like this. You'll notice that they're in standard form, so everything's lined up. The x's, the y's, and the constants. So you'll notice that I purposely set this up so that it works out nicely. When you add 6y and negative 6y, they cancel one another out. So that's why it's called elimination, because one of the variables will eliminate, will get canceled out. And then you add all the other columns. So 5x plus 3x gives me 8x. I have 0 there. And then negative 32 plus 48 is going to give me a positive 16. And what I've done is I now have an equation with one variable that I could solve for and get a numerical value, divide by 8, x equals 2. That tells me that the x value of the point of intersection is 2. I'm going to now sub that back into either equation, just like yesterday. Both give you the same answer to get the y value. So 5 times 2 plus 6y equals negative 32. I'm just randomly picking the first equation. I have 10 plus 6y equals negative 32. I subtract the 10 over, 6y equals negative 42. Divide by 6, y equals negative 7. So my y and x value are there. I'm going to write them as coordinates 2 comma negative 7 is the intersection point of the two lines. Now, the second example, I'm not going to do the whole example for you, but you'll notice that it's set up so that the x's would eliminate. So if you added the two equations, your x's could eliminate. I just wanted to show you, well, I'll go through the problem. I wanted to show you that it could be either variable that eliminates. So if I add the y column, I have 2y, and then I add 3 plus 3, I have 6. So therefore y equals 3. And then I sub in to find x, sub into either equation. So 4x minus 3 times 3 equals 3. So I have 4x minus 9 equals 3. 4x equals 12. I'm adding 9 on both sides. So my x value is also 3. So 3 comma 3 is my point of intersection. Now they're not going to be set up this easily every time. So we're going to look at some other examples now where, hold on a second, okay, where you have to do a little bit more work to do the elimination. So if you look at these vertically, none of these variables will eliminate. So we get one of the variables to eliminate by using the equality property of multiplication, which says that if you multiply every term of an equation, it's still the same equation. So if I look at the y's, you'll notice that 15 and then the least common multiple of these would be 15. I could get this y term to become a negative 15y, which would add with the positive 15y and cancel if I just multiplied this by 3. So I would have to multiply the whole equation by 3 in order to not change the equation. So I'm going to go parentheses around the equation, very important, to show that I'm multiplying every term. So this is now going to become 21x minus 15y equals 51. So I have not changed this equation because I multiplied everything by 3. The first equation is going to remain the same. I'm going to copy negative 2x plus 15y equals negative 32 so that I have everything lined up. And now I can add my equations vertically. So the y's eliminate. I have 21x and negative 2x, that's 19x, equals, and then negative 32 plus 51 is also going to be 19. And I divide x equals 1. Once I have my x value, I can plug it in to get my y value. I'm going to use the second equation, 7 times 1 minus 5y equals 17. Remember, you can use either equation. 7 minus 5y equals 17. I'm subtracting 7, so I have negative 5y equals 10, y equals negative 2. So my point of intersection is going to be 1 comma negative 2. Now, at times, you may have to multiply both equations to get a variable to eliminate. So let's look at some more examples. If you want to pause the video and try to see if you could figure this one out, you're looking at the x's and the y's. I could get the x's to become the least common multiple of 4 and 3 is 12. So I could get them to become 12x and negative 12x. And the least common multiple here of negative 3 or 3 and 8 would be 24. So I could get one of them to become positive 24 and the other to become negative. It's important that you have opposite signs though, right? So I'm going to go with getting the x's to eliminate. So I'm going to multiply the first equation by 3, but then I would multiply the second equation by negative 4. Okay, it doesn't matter which one's negative, but one of them has to be negative. So I have now 12x minus 9y equals 30 for the first equation. And then for the second one, I now have negative 12x positive 32y equals positive 16. And now I can add. The x's eliminate. I now have positive 23y equals 46. I divide by 23 and y equals 2. I'm going to now sub in to find x. I'm going to use the second equation, 3x minus 8 times 2 equals negative 4. So 3x minus 16 equals negative 4. I add 16. 3x equals 12. X equals 4. So my point of intersection is at 4, comma 2. Okay. And then I have one more example here where I purposely did not line things up. So I'm not going to do the whole problem, but you would want to make sure that your terms are lined up first before you can do an elimination. So I would need to move this negative 4y over to the other side. I would add 4y to get my x's and y's on one side and my constant on the other. So this would become 3x plus 4y equals 9. And then in terms of like elimination strategy, you could get either x's or y's to cancel. Let's say we wanted the y's to cancel. You could get these to become 12y and negative 12y, or you can get the x's to become 15x and negative 15x. So if I were to eliminate y's in this situation, maybe I would multiply this one by 2 and this one by negative 3 to get 12y and negative 12y. And then you would proceed from there. Okay, and you're going to practice these for homework tonight. You have a bunch. Towards the end, the problems become a little bit more challenging, more like level 3 problems. So do your best to just give your best effort and not give up early in the problem. Okay, I'll see you guys soon. Thanks.